beside the cutting calculation for bent-up reinforcement, what else do we have? Like the cutting calculation of the stirrup. The cutting calculation of the stirrup is, we can do the same, mainly depends on what it is. Straight length? And what else besides the straight length? Stirrup, what is the formula for bent-up reinforcement? The straight length plus the diagonal length. Is there a diagonal length for the stirrup?
No.
That is, the straight length plus bending adjustment value plus length increased by hook. It does not have a diagonal length, so it is easier to calculate. But for the stirrup, we sometimes make the hook angle to 135 degrees, not 180 degrees like we did just now. Sometimes the angle is 90 degrees. Of course, it is also possible to make it into a 180-degree angle. There are many types. At this time, can we just look up the table like we did before? 180 degrees, 90 degrees, 135 degrees. No, we don't look up the table. Why? Because the shape of the stirrup is relatively fixed. We need to bend 3 angles and make a hook at the last corner. So its calculation is relatively fixed. To increase the accuracy of our calculations and convenience, we will follow the outer length of the stirrup plus the stirrup adjustment value. Then what is the outer length of the stirrup? The outer width of stirrup plus outer height. Stirrup adjustment value. It includes the bending adjustment value above and hook adjustment value. That is to say, the calculation of stirrup are relatively easier than bent-up reinforcement. You just need to measure its length. What length? Straight length plus adjustment value for the stirrup. For the stirrup adjustment, it include the length increased by the hook and the bend adjustment value. We can see from this table. You can check this table directly in the future. You can look up this table, then calculate its diameter length, just the diameter length of the stirrup. What does it contain? What do you need to measure?
Outer length. Inner length.
In fact, no matter it is outer or inner length, it doesn't matter to you because the stirrup adjustment value already taken its differences into consideration. Let's take the example of number 8 rebar. For number 8 rebar, how much is the difference between its inner and outer lengths? The difference is 2D. That is, when you measure the inner length, it will be 2D smaller, so how many sides does it have?
4 sides.
How much is the difference between the inner and outer lengths?
8D.
8D. If the diameter of the rebar is 8, then how much do they differ?
64.
Which means when you measure the inner length, it will be 64 shorter than outer length. But when we adjust the adjustment value of the stirrup, has it been added back? It has been corrected 120 minus 60. That means no matter if it is inner or outer length, then the straight length, and add the stirrup adjustment back. Okay, after measuring the straight length, here if you measured the outer length, add the adjustment value for outer length. If you measured the inner length, add adjustment value for inner length. This is the adjustment for the stirrup. It's very simple, compared with bent-up reinforcement. Right now, we will also practice it. Calculating the reinforced concrete. We still use the reinforced concrete member here. Calculate the adjustment length of its stirrup. Now start calculation the parameter. Parameter.
Then put this inside the edge. Next time, let's add 12 first. And then after subtracting 200.
This is very simple. Upload after finishing.
Multiply by 2 and add an inner bag. Just the investigation of outsourcing and the adjustment of outsourcing size. Then add 50 and let's calculate. If you want to understand it immediately, We have long understood multiplying by 2 and adding an inner package. Just do an investigation on outsourcing. Understanding the requirements for the recruitment standards of environmental sanitation workers. Multiply by 2 and add an inner bag. Standardization of outsourcing. And it is the standard for sanitation recruitment. Multiply by 2 and add an inner bag. Just do outsourcing plus 2. Understanding the requirements of the sanitation recruitment standards. Multiply by 2 and add an inner bag. Is there standardization for outsourcing? Do you still need to upload?
Upload. Upload after finished. Upload quickly. Upload after finished. Okay, let's take a look together. Classmates who have finished. It is the same here. Do it quickly. The height and width of this member. What is its width here?
200.
200 minus 2 protective layers. How many? How many is a protective layer?
25.
We can calculate the inner and outer lengths quickly.
150.
Same here. How many are this side? 500 minus 2 layers.
450.
Right here. This layer is in here.
25.
25 for the side, 25 for the side. So the result is 200.2 times 25 plus 500-2x. 2 by 5, the same value, minus its length by 2 protective layers. How many height and width in total?
2.
Plus outer length. What is the outer length adjustment?
50.
Equal to
1250.
the classmate here. Undoubtedly, calculated the right value. This is the example for stirrup. Of course, sometimes when we calculate the stirrup, what we just calculated is just 2 stirrups. Sometimes we will calculate 4 stirrups, 6 stirrups, even 8 stirrups, or 1 stirrup like this. For example, for these 4 stirrups, we must pay attention for 4 stirrups. We saw it wrapped. The 3 rebars on the left, and the 2 rebar were wrapped. The 3 rebars on the right, and the 2 rebars on the left wrapped the 3 rebars on the left. Thus form a 4 rebars wrap. Here are 3 rebars and here are 3 rebars. 2 by 2 rebars, total 4 rebars. For 4 rebars, we must consider the spacing of the rebar. Make sure the spacing of longitudinal reinforcement. If the longitudinal reinforcement are too dense, it will interfere inflow of the concrete aggregate. So our pure stability. We know our pure stability. It has nature of lime, shrinking character. This will have an impact on our reinforced concrete member. It is possible for our concrete don't have enough compressive strength. According to our construction standards, the spacing for the upper beam should more than this, no less than 30 millimeters, 1.5 D, and the lower beam is slightly smaller. Only when you guarantee this, the reinforced concrete we pour is qualified. The same applies when you calculate the span of a stirrup. You must consider the spacing of the longitudinal reinforcement of the stirrup.